Dear student, let's see in this video actually the quantum chemistry. This topic, the last of the structure of atom unit. Okay, so initially, first of all, known the quantum chemistry of its a fundamental, and next there is a quantum numbers and the rules for electronic configuration filling for electron. Okay, so the quantum means there is a microscopic particle. That is explained. There is a microscopic particle properties. That is explained. There is a quantum. Okay, the thermodynamics means there is a macro particle level. So the micro particle and macro particles depends on that they have explained in the statistical thermodynamics. So this microscopic particle level properties they have explained there is a quantum chemistry. So here there's a theoretical science. There's a theoretical theoretical part of the science. Okay, so it's proposed by this the Schrödinger as well as Heisenberg. Okay, because this quantum means there is a mechanical theory once it's a development by the Heisenberg as well as the Schrödinger. The fundamental equation of the Schrödinger equation, the Schrödinger wave equation of there is a fundamental equation. Here there is a h cap psi is equal to E psi. Okay, so the h cap psi is equal to E psi. Here psi as a wave function, and there is a h cap as a Hamiltonian operator. There is a Hamiltonian operator. Okay, Hamiltonian operator, and there's E is for there's eigen function, eigen value because there is a psi as a wave function. So this Katsukap as a Hamiltonian operator, this I as a the wave function, this eigen function, this eigen value. So it's nearby of that eigen value that is also called as a eigen functions. Okay, so this the Schrödinger equation is the time dependent equation. So another one Schrödinger equation most familiar, most of the persons are known. I can written here there is dou squared psi divided by dou x squared plus that's dou squared psi divided by dou y squared plus dou squared psi divided by dou z squared plus 8 pi squared m divided by h squared e minus v there is a psi is equal to 0. Okay, so this is the nothing but there's a kinetic motion because we know that there's a total energy is equal to kinetic energy plus there is a potential energy. We need that kinetic energy. So what we can get kinetic energy is equal to for there is a total energy minus for potential energy. So this total energy is representing as a E and there is a potential energy is representing as a V. So the E minus V is nothing but for there is a kinetic energy. Okay, so the motion of electron possessing as a kinetic energy that is representing as a E minus V. So this entire equation it's also is called there is a Schrödinger wave equation. Okay, so here this another one simplification. Here there is a del squared that is equal to for there is nothing but for Laplacian operator, Laplacian okay, or Laplacian operator. Okay, so this del squared as a Laplacian operator. Here there is a del squared that is equal to dou squared psi divided by dou x squared plus dou squared psi divided by dou y squared plus dou squared psi divided by dou z squared. So we can exchange this as well as there is a 8 pi squared m divided by h squared. So we can exchange this all term with there is a del squared. So that's why we can get that formula. There is a del squared. There is a del squared y is equal to 0. This is one of the Schrödinger equation. Here there is a this the psi squared is nothing but or psi as a wave function or wave amplitude and the psi squared as a probability density. The probability means there is a finding of an electron in an atom. That's a maximum. Next actually there's a node. This node is nothing but see this is an atom. It consists in the central part of its a nucleus. So this first orbit there is a 1s orbit 1s The electron cloud is maximum this side. Actually, the electrons is sometimes nearby of nucleus and sometimes far off nucleus is like that. We already studied in the previous video. The electron cloud has a maximum in this side. Okay, so the electron cloud is a maximum in this side. So this is the oneness. What about the next level of energy state? There's a 2s. Yes, very good. There's a 2s, oneness, and there's a 2s. So between these two, here also it's a like that. The somewhere is electron density is a maximum, and somewhere is electron density is a minimum. So here this area, these two area as a electron density as a maximum, but middle of the between these two, that is a electron density is around, that is equal to 0. Okay, so whenever that the electron density is equal to 0, that area is called node. Okay, if there is a plane, there is a nodal plane. Okay, so the node actually is a the maximum their electron density is equal to 0. Okay, so this is a very important, everyone keep it your mind. Okay, so next this node can be representing, there is a mathematical formula, that is angular node, there is nothing but for L. Okay, and there is a radial node, there is nothing but n minus L minus 1, and there is total node, or sometimes it's normally saying there is a node. Total node is nothing but n minus L minus 1 plus L, plus L minus L is cancelled, we can get there is a n minus 1. So this formula, there is finding the node based on the mathematical representation. For example, see the s orbital, or here there is a orbital and L value. Okay, L value. See s orbital, their L value as a 0, p orbital L value as a 1, and d orbital L value as 2, f orbital L value as a 3, and like that is going. So here suppose 1s orbital, what is the number of node is there? So node here, what is the principal quantum number? Yes, 1. So according to n minus 1 formula, that is a node that is equal to 1 minus 1, that is equal to 0. So from this equation, from this formula, we cannot or we can get in the 0 node of 1s orbital. Suppose, see, there's a 2s orbital. Here, what is the principal quantum number? Yes, there's a 2 as a principal quantum number. So that's why here there is a node is equal to 2 minus 1. We can get what? Yes, one node is there. Okay, so like that, whatever that orbital they have given with its a quantum number, we can easily finding the node. Next, there is a radial node. What is the radial node formula? Yes, very good. Yes, n minus L minus 1. Suppose the 2p orbital of radial node, what? Radial node here, there is a n value as a 2, and p orbital of its L value, yes, it's a 1. So minus 1, we can get there is a 0. So similarly, there is a 5d orbital. What is the radial node? Here there is a radial node that is equal to n value as a 5, and d orbital of its L value as a 2, and its a formula of its minus 1, we can get there is a 2, there is a radial node. Okay, so that's why whatever that orbital of they have given with the principal quantum number and the known of L value, we can get in the radial node, and also simply saying angular node, or there is a node. Okay, so it's a node or nodal plane. There is a very important maximum of the question is asking in the JE as well as NEET. Okay, suppose the graph sometimes is given 1s, there's node is equal to 0. So node is equal to 0 means they have representing diagram like that. So here there is a psi squared as considering x-axis or y-axis, whatever that. Here is r. So here there is a no, this diagram is like that is appeared, and also another orbital of there is 2s. We know that's 2s consisting one node. So one node means, so this diagram, this and this. Okay, so this is a one node. Okay, so here there is a formula, there is a psi squared r. So there is comes slow and decreases and increases and that. Okay, so this is a one node. Okay, this is a node as a 1. So similar like that, whatever that orbital they have, we can easily finding the node. Next topic, actually there is a quantum numbers. These quantum numbers nothing but the address of electrons. Okay, so exactly where that electrons are presented or possessed in the atom of our orbit. Okay, the numbers actually required to define an electron completely in an atom are called this quantum numbers. Basically, the quantum numbers as a 4 types. Initially, the 3 is find out last one, that is spin quantum numbers. Okay, so first case, so there's a principal quantum number. There's a principal quantum number. Okay, principal quantum number, and that is second as there is a azimuthal quantum number. Azimuthal quantum number. Okay, and third one as a magnetic quantum number. There is a magnetic quantum number, and fourth case as it's a spin quantum number. So among these four only there is a quantum numbers. Must very important in that four quantum numbers. So because it's a very essential for finding the lot of the quantum mechanical properties. Let's we study that is a, or let's we know that the step by step the all four quantum numbers. The first quantum number, that's a principal quantum number, that is representing as a small n. It's proposed by Bohr. There is a proposed. It's representing the energy level of an orbit. Energy level of orbit. Okay, and it's indicates a number of orbits. Okay, there's a number of orbit. Indicating the number of orbits, and there's a size of orbit, size of orbital. Then it's representing as a integral value. For example, that integral 1, 2, 3, 4, etc. So these points are important, and as well as see this principal quantum number and the cell. First there is a subcell, and there is a principal quantum number that is representing as a n. Suppose the principal quantum number as 1, the subcell as s orbital is there, and the principal quantum number is 2, s orbital and p orbital is there, and principal quantum number as 3, here s orbital, p orbital as well as d orbital, and principal quantum number is 4, s orbital, p orbital, d orbital as well as f orbital. So like that, that depends upon that principal quantum number, the subcells are presented or orbitals are presented in that every the energy levels. Okay, the maximum number of electrons are finding, that's maximum number of electrons, that is equal to 2n squared. Suppose here n is equal to 1. What is the number of electrons? Yes, 2 into 1 squared. So that is 2 into 1. What? That's 2. So that's why the principal quantum number n is 1. It consisting s orbital. The maximum number of electrons in the s orbital, that's 2. Here representing as a orbital, or there is a subcell. Here is number of electrons as a maximum. Okay. So s orbital maximum 2 electron, p orbital maximum 6 electron, d orbital as maximum 10 electron, f orbital as maximum of electron 14 electrons. So like that is going. So the depends on that, the n value as a 1, 2 into 1 square, that is equal to 2. So n is equal to 1 means consisting only s orbital. That s orbital is maximum of electron, 2 electron. Suppose C, there is n is equal to 2. What is the maximum of electron? Here there is 2 into 2 squared. So it's simply representing 2 into 2 into 2. There's 2 into 2, 4, 4 into 2 of 8 electrons. So 8 electron is there. So we know that the principal quantum number as a 2, that kind of possessing s orbital as well as p orbital. The s orbital is maximum of electron 2 and p orbital maximum of electron 6. So 8 electrons as both the s orbital of electron as well as p orbital of electrons. Okay, so that's why here as a 8 electron is there. So whether they have finding the different energy levels, the number of electrons is easily finding that this 2n squared formula. Okay, so this formula is important. And the angular momentum of any orbit, there is a angular momentum of any orbit. So this one of the formulas there. Actually angular momentum mvr, that is equal to n h pi 2 pi. So this formula already we teach already given in the previous video. So this angular momentum, that is a mvr is equal to n h cross also. We know h cross equal to h pi, that's a 2 pi. So that's why here as a n into h pi 2 pi, like that the formula is changed. The second quantum number, there is a azimuthal quantum number. There is second quantum number as a azimuthal quantum number. Okay, so this azimuthal quantum number can be representing as a small l. It is proposed by Sommerfeld. It's a Sommerfeld they have proposed in the azimuthal quantum number of, that is a second quantum number. Actually it representing the energy of subcell. Energy of the subcell. We know that the subcell is nothing but orbital. Okay, Then next it explain the shape of electron cloud. Shape of electron cloud. Shape of electron cloud. And the uh, number of subshell. Okay, second a third category as a it's number of subshell. Number of subshell. And this representing as a L as a symbol. From this symbol, the subshell or orbital. Okay, orbital, and there is L value. L value, this is important. Okay, the subshell or orbital and L value. We know that the four kind of orbital is only is presented. So that is a s orbital, L value as a 0, and p orbital, L value as 1. Then d orbital, L value as 2, and f orbital, L value as 3. So like that, the subshell increases s to f, the L value also increases. Okay, suppose see, if we assume L as a 0, L value as 0, the what kind of orbital is there? There is only s orbital. So here the number of the subshell is finding the formula. Number of subshell, number of the subshell, that is equal to 2l plus 1. That is the formula. Number of subshell, that is 2l plus 1 formula. Suppose L is equal to 0, L is equal to 0, we can get there is a 2 into 0 plus 1, that is equal to 1. So there is s orbital, only one set of box is there. Okay, box like that, there is only one is there. Okay. Similarly, suppose L is equal to 1, L is equal to 1, we can go to substitute that formula. 2 into 1 plus 1, that is equal to 3. So 3 orbital is there, or 3 subshell is there. So what are that 3 subshell? We know that p orbital consisting p set orbital, there is a px, py, pz, because this p orbital is a directional orbital. There is a x, y, z is like that. So we can separating that 3 box like that. There's a px, there's a py, this is a pz. So that's why this formula, we can go to that 2l plus 1, this formula we can finding the number of the subshell or number of the orbital are presented. Okay, so another one example, suppose L is equal to 2. So L is equal to 2, what kind of orbital is there? L is equal to 2, there is a d orbital. So the L is equal to 2, the d orbital is there. So actual formula, there is a 2 into 2 plus 1, there is a 5. So 5 is there. What are that 5? dxy, dxz, dyz, and dx squared minus y squared, dz squared. So that 5 orbits are the in presented in the d orbital. So there is a d orbital is classified in two types. There is a this all are called, there is a non-axial orbital, that is T2g orbital. These two are called, there is a axial orbital, there is a EG orbital. It will study for upcoming coordination chemistry coordination topic. Okay. Coordination as well as D and F topic they have covered in this d orbital splitting, whether there is a T2g orbital and EG orbitals like that. Okay. The next, the maximum number of electrons are presented in the subshell. So they have also one formula. There is a maximum number of electrons in subshell. Okay. So we know that s orbital consisting only 2 electron, and p orbital consisting maximum 6 electron, d orbital consisting as a 10 electron, and f orbital is consisting as a the 14 electrons. The maximum number of electrons in the subshell, actually this formula, there is a 2 into 2l plus 1. Okay, so this formula we can be rearranged. So 2 into 2 as what? 4. There is a l, 4l. 2 into 1, there is a 2. So 4l plus 2 is like that also, this formula is given. See, the s orbital is maximum 2 electron is consisting. So s orbital of its l value 0. So s orbital of L value is equal to 0. We can go to this, substitute this formula. That's 2 into 0 plus 1. So here 2 into 0, 0. So then 2 into 1, there's 2. There's 2. Okay, the 2 electrons is maximum is consisting. So similar like whatever that is subshell, they have maximum number of electrons, easily finding this formula. Next, as orbital angular momentum. Orbital angular momentum. This orbital angular momentum, here there's a root of L into L plus 1 h cross. We know that h cross equal to h pi 2 pi. So that's why this formula, there's a root of L into L plus 1 h pi 2 pi. Okay, so this formula is very important. For example, the s orbital. the s orbital L value is equal to 0. S orbital, that is L value is equal to 0. So this formula using, that is the root of the 0 into, that is 0 plus 1 h by 2 pi. So we know that 0 into anything, that is equal to 0. For s orbital, there is a orbital angular momentum that is equal to 0. Suppose p orbital, this p orbital, the L value is equal to 1. So the orbital angular momentum, root of the 1 into 1 plus 1, that is h by 2 pi. So we know that 1 plus 1, 2, 1 into 2, that's 2. So that is equal to for root of 2 h by 2 pi. Okay, so there is a p orbital of angular momentum. Then similarly the d orbital, that's d orbital, we know that L value is equal to 2. So the orbital angular momentum for d orbital, that's 2 into 2 plus 1 h by 2 pi. So 2 plus 1, 3, 3 into 2, that is equal to 6. So that's mean root 6 h by 2 pi. That is the answer. And similarly, there is a f orbital. There is f orbital, there is L value is equal to 3. So the orbital angular momentum of f orbital, that's root of the 3 into 3 plus 1, that is h by 2 pi. So that's why 3 plus 1 as 4, 4 into 3 as 12. So that's why root of 12 h by 2 pi. So the s orbital angular momentum for 0, p orbital angular momentum for root 2 h by 2 pi, and d orbital root 6 h by 2 pi, f orbital root 12 h by 2 pi. So there is a sometimes asking the NEET and JEE level questions is directly in this content. Okay, so the next quantum number, there is a third quantum number. This third quantum number are called, there is a magnetic quantum number. There is a magnetic, that is quantum number. This magnetic quantum number, they have representing as a M or sometimes ML, like that. Okay, so this proposed by, that's Landé, scientist of Landé, they have proposed the magnetic quantum numbers. Generally, this magnetic quantum number, it can explain the orbital orientation. Orbital orientation, or orbital that is equal of all, or there is a subcell. There is a orbital, another name, there is nothing but there is a subcell. That subcell or orbital of its orientation. Okay, there is a orientation, it can be explained. And it behaves as the value from, there is a minus L to, that's plus L, within the 0 or including the 0. For example, see the s orbital, it possesses as a L value 0. So whenever that L value is equal to 0, this ML also 0. Okay, suppose see the p orbital, the L value is equal to 1. This 1, there is a plus 1, the L value is equal to 1. Here there is ML is nothing but plus or minus 1 comma 0. That is can be representing minus 1 comma 0 comma plus 1. So 1 2 3, there is a ML value increasing up to plus or minus 1 and 0. So similarly, see there is a d orbital, there is a L value is equal to 2. So that's why here ML, what, there is a ML, there is a plus or minus 2 comma plus or minus 1 comma 0. It can also be written as minus 2 comma minus 1 comma 0 comma plus 1 comma plus 2. So there is a ML value, there is a magnetic quantum numbers that can be explained the scientist of Landé. So similarly, see there's f orbital. What is the f orbital of L value? Yes, very good. There is a L value for 3. So actual ML, there is a plus or minus 3 comma plus or minus 2 comma plus or minus 1 comma 0. So similar is like that of the minus 3 up to plus 3. That is explained in the magnetic quantum numbers value. Okay. So then next, the spin quantum number. Actually, there is the spin quantum number. There is fourth quantum number. There is spin quantum number. Okay, the spin quantum number that is explained by the there is Goudsmit and Uhlenbach. Goudsmit on and there is Uhlenbach. Uhlenbach. Okay, so it can be representing as a small essay. In generally, we know that atom of its a fundamental particle, electron, proton, neutron. Those fundamental particle of the proton and the neutron, they have consisting as a nucleus. But in the case of electron, it is possessed as an orbit, they have revolving around the nucleus. So this quantum number that is describing by the, it's a spin of electron. Okay, there is a spin of electrons is mostly, there is a explained by the spin of electrons. In generally, the electron, if they have clockwise direction, or it's like that representing, there is a clockwise direction, the spin is a plus 1 by 2. Suppose that electrons is anti-clockwise direction, that spin is equal to minus 1 by 2. Okay, so the electrons they have whether the clockwise direction or anti-clockwise direction. If that electron has a clockwise direction, the spin value that is a plus 1 by 2. If that anti-clockwise direction, the spin value has a minus 1 by 2, minus of. Okay, so similar like that of the previous case, spin quantum number also possessed as a spin magnetic moment. There is a spin magnetic moment. This magnetic moment that is equal to for root of the s into s plus 1 and h pi 2 pi. So this formula is very important for finding the spin magnetic quantum numbers or the spin magnetic moment of the every electrons. Okay, so this all or that is very important of the basically the quantum numbers, very important in the NEET and JEE level problems. Next, actually, the rules for filling of electrons. Okay, there's rules for filling of electrons. So these rules actually there's four types. Four types of rules is there. Four types among four types. Majorly there is three types in the most of the textbooks, even in our school books also. The first as there's alpha principle. Okay, that's alpha principle. Alpha principle. Okay, so the next case as n plus L value or n plus L rule, and there is third one as a Kunz rule. Okay, Kunz rule, and fourth was there is a Pauli exclusion principle. Okay, there's a Pauli rule. Okay, this Pauli's rule. Okay, so among these four rules are very important in the electronic configuration. First of all, we keep it our mind whenever that electrons are filled in the lowest energy state. Lowest energy state, the electrons are filled first. Okay, there is the electrons are filled first case. So the energy as principal quantum number is directly proportional. So that's why the 1s and 2s, 2p, 3s like that is going. So the 1s has the lowest energy. That's why for every element they have filled in the first electron in the first cell of 1s orbital. The next 2s and 2p is like that is going. Okay, so simply keep it your mind whenever that electrons are filled at the orbital of lowest energy state. Okay, so based on that the n plus L rule is also is following. For example, these two rule is most resemble to each other because this n plus L rule as well as alpha principle is similar kind of that information or saying. So this energy lesser orbital, the first electrons are filled. Okay, so according to that alpha principle, there is 1s and 2s, 2p, 3s, 3p, 3d. So here so and 4s, 4p, 4d, 4f like that is going. Okay, so this 1s is first filled and 2s, 2p, and 1s is first filled and 1s, 2s and 2p, 3s and 3p is like that is going. Okay, so this electronic configuration is based on that energy state, energy level of orbital. Okay, so similarly the n plus L rule here, see there's 1s, 2s, 2p, 3s and 3p. There is a 3d, 4s less like that is going from the based on that principal quantum number. Okay, so this n plus L rule is followed out. Here the n as a principal quantum number, L as a azimuthal quantum number. There is a L as a different of orbital, it possesses a different value. Here there is n as a 1, s as a 0. So there is 1 plus 0, what we can get as 1. Here as n as 2, s the L value as 0, this 2 plus 0 as 2. So from that there is a n plus L value increases. N plus L value actually increases, actual energy also increases. So energy whenever that lesser, there the electrons are initially filled. Okay, so then next one thing, if same n plus L value, if same n plus L value, there is we can go to next as the principal quantum number. Okay, the principal quantum number that is directly proportional of energy. That's all, over. Okay, now you can come to here. This 1s possessing as n plus L value 1 and 2s there is 2. Here compared to 1 and 2, this 2 has a higher value. That's why the n plus L value higher, energy also increases. So compared to 1s and 2s, 2s has a higher energy. That's why the electrons are filled as a initially 1s orbital. And similarly, the 2s next of 2p, there is n as a 2 and p orbital of L value as a 1, 2 plus 1 as 3. So here see these two. Here 2 n plus L value, here as a 3 n plus L value. Comparatively, the 2p orbital has a higher energy. Okay, because of n plus L value, this is the highest. So that's why before 2p orbital electron filling this 2s electron orbital initially filled. So it's like that the 3s 3 plus 0 there is 3, and here see the n plus L value as the same. So what we can get here, if same n plus L value, next see the principal quantum number. The principal quantum number increases, high energy also increases. Energy whenever increases, they have electron densely filled. Okay, so because this very important point, lowest energy state, the electrons are filled first. Okay, so the next there is a 3p. There is 3 plus 1, that is 4, and here as 3 plus 2, that is 5, and here as a 4 plus 0, that is 4. See here, these 3d and 4s, this 3d n plus value as a 5 and 4s n plus value as a 4. So comparatively these two 3d orbital they have highest energy because n plus L value is increases, energy also increases. That's why this 3s 4s electron is come to here, 3d orbital is comes to here. Okay, so this is nothing but for it is also similar of alpha principle. Okay, I think if you very clear in the alpha principle as well as n plus L rule. Okay, the next actually this Hund's rule, this multiplicity rule, it's also saying multiplicity rule. This rule is simply saying the electrons initially half filled overcome, then there is a pairing. So then this electrons must be the opposite spin of rotation, and the Pauli exclusion principle last this equal half filled more after then there is a more than half filled will come. Okay, so simply these four rules for writing the electronic configuration. Some elements they have exception in the electronic configuration. So that is for example chromium. See chromium atomic number 24 here 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5 because this actually 4s2 and 3d4 is like that it is in our general knowledge kept it, but this d orbital is less than it's a half filled 1 2 3 4. So this d4 this less than the half filled. So the electronic configuration whenever the orbital or orbitals or orbital there is a half filled. Okay, that is half filled or there is a completely filled. So those kind of electronic configuration or there is a stable. Okay, so whenever the atom whether they have losing electron or gaining the electron depends on that whatever that process they have attained the stable state of electronic configuration. Okay, so for that reason this 4s2 one of electron is completely transferred into 3d orbital. So that's why 3d4 is will convert to the 3d5. Okay, so this is the correct, this is not correct. Okay, so similarly see copper, this 29 actually its electronic configuration as a 1s2 2s2 2p6 3s2 3p6 4s 2 3d9, but here this 4s1 3d10 that is a correct because this 3d10 has completely filled d orbital. See there is a 1 2 3 4 5 6 7 8 9 10. So there is a completely filled, so that's why there is a more stable. Okay, so these two are the exception of actual electronic configuration. Okay, if you liked in this video you can subscribe and share your friends. Thank you very much. I think this structure of atom unit is completely given in this YouTube channel videos. Okay, we will see next the NEET and JEE syllabus oriented topic. As well as in this unit will completing will be completing some problems. Okay, thank you very much.